Hi everyone. In this chapter we're going to be looking at systems of linear equations. In this lesson we will take a look at how to solve a system of equations algebraically by using a method called substitution.
Okay, well, to solve a system of equations, which means, once again, and I know we said this before, but which means to find the point of intersection between two lines, you can use a variety of different methods. And what we're going to start to do now is we're going to transition over and start to look at algebraic methods. We've already taken a quick look at plotting. Okay, we did it by hand and we used the calculator. Now we're going to look at some algebraic methods. And algebraic methods, basically for what we're going to do here, fall into two categories. We're either going to use elimination or we're going to use substitution. In this particular lesson here, we're going to look at substitution. Okay. Now the basic premise of these algebraic methods is basically this. We're going to take an equation that's got two equations, two variables, and what we do is we reduce it down to a single equation with one variable. Because if you've got, for example here, if you take a look at 3x plus 2 is equal to 8, okay, I can solve this. It's a simple equation. It's one equation, one variable. So what I do is I bring over the 2. I get 3x is equal to 6, divide, and I get x is equal to 2. Okay, that's easy enough for me to do. So when I've got two equations with two variables, let's say that I've got something like, I don't know, like 6x plus 3y is equal to 14, and then, 5x minus y is equal to 10. I've got two equations here with two variables. Or think of it like this. Maybe it makes more sense to look at it like this. Can I solve this equation right here? 6x plus 3y is equal to 14. Well, if by solve you mean find the point that satisfies the equation, the point, well, no. Because there's an infinite number of points that satisfy that equation. Okay, they'd all be considered, things that satisfy this. I need more information. I need a second equation, okay, to give me enough information to solve this. And by the way, if I threw in a third variable, if we threw in a z in there and solved that system, okay, I would need a third equation to solve that. So, and the goal is the same. I take this, okay, two equations, two variables. Again, I apply a little bit of work here to convert this into one equation, okay, one equation, one variable that I solve. That's my goal here. Now, with substitution, what we do is this, okay? What we're supposed to do here with substitution is you're going to choose one of the two equations that you're given and isolate one of the variables, preferably the one with a coefficient of 1. Basically, you want to be lazy. You want to take the easiest way out, okay? Now, then we're going to substitute this new equation for that variable into the other equation. Now, that maybe doesn't make a whole lot of sense to you. And so what I'm going to do here is I'm going to set this thing up so maybe this makes a little bit more sense. Experiences has told me that when we start to take a look at solving systems of equations, I mean, there are the two methods. There's substitution and elimination. But it turns out like most people tend to gravitate towards elimination and away from substitution. However, this one here can be used, I think, in a wider variety of circumstances. So I really want you to get a sense of why this is a good method here. So what I'm going to do to start off with, I just want to graph a line for you. We're just going to make it a very, very simple line here because I just want to make a little point with it, okay? Let's say that we graph the line, let's make it straightforward here. Y is equal to, let's say, negative x plus 4, okay? So negative x plus 4 has got a y-intercept of 4, and then it's got a slope of negative 1, meaning I'm going to go down 1 over 1, down 1 over 1, okay, negative rise, positive run, negative rise, positive 1. And I'm just going to keep doing this until I get a whole bunch of points. Maybe I'm going to go off the screen here, but I'm going to give myself a whole bunch of points here. Then I'm going to go backwards, up 1, back 1, up 1, back 1, and again, until I go off the screen here, basically. I'll do it one more. And so now, connect the dots. Whoops, connect the dots. There's my line. Okay. Now, what I'm going to do here is I want to identify a general point on the line. So let's identify, let's say this point right here. Okay, I'm going to zoom in a little bit on this because I really want you to catch the idea here. This is this equation right, y equals negative x plus 4, okay? So any point on this line, okay, I pick one that's not on a lattice point here because I try to make a point here. this point on the line here has the coordinates x comma y. Those are my general coordinates for any particular point. But you know what? I can do a little bit better than that. And this is the essence of this method of substitution. I can do better than that. Y is the dependent variable. It depends on x. Okay? And in this case, I can tell you exactly how it depends on x. Y is the same as negative x plus 4. So what I can do here is I can actually rewrite the coordinates of the point along this line. See, at this point right here, this point x comma y, I mean, I'm telling you that the point on that line is x comma y, but really, x comma y is this really general, vague point. It's just a point. To make this specifically along this line right here, I need to be a little bit more specific with how the y depends on x. And so what I'm going to write here is x comma, well, y is negative x plus 4. Okay? That's the y coordinate. Where do I get that? Well, from over here. That's the equation of the line. Y equals negative x plus 4, x comma y, x comma negative x plus 4. Okay? Now, there is another way that we could do this. It's not quite as common, but there is another way that we could do this. I can bring this x over and bring the y over. Okay? And now I can come over here and I can, pick a point. Here's another point here, which of course is x comma y, but I could rewrite that. Now this is not nearly as common as doing it this way right here, but this is still possible here. I could rewrite this point, okay, as negative y plus 4 comma y, and basically treat it as if the x depends on the y here. Now, it is possible to reinterpret things like that, but that is not the standard way of doing it. So sometimes, a lot of times people find this an awkward way of thinking about it. But this is the idea. This is how I want you to think about it here. That any point along the line, y equals negative x plus 4, has the coordinates x comma negative x plus 4. And so what we end up doing is we take that point, the coordinates of that point from the line, and I'll zoom out here. So our method is you isolate one of the variables, which is what we just did. So we want to catch dependence. We want to see the dependence, okay, of one variable on the other. Now, it doesn't have to always be y dependent on x. However, it will often be y dependent on x. And we're going to substitute that new equation, or that point. If you don't want to think about it as the equation, okay, you can think of it as the point, okay, for that variable into the other equation, and then we're going to solve, because the result here, okay, our result is one equation, one variable, and that can be solved quite easily. And then what we do is we choose one of the equations to substitute and solve for the one that we're missing here, the variable that we're missing. That'll make a little bit more sense once we start going through the examples here. But that is the main idea here. We're going to identify dependence and take how the one variable depends on, for example, how y depends on x in one equation, and we're going to assume that that is true in the other equation. Now what will happen is because we're only overlapping at one point, that kind of dependence only exists at one point, and that allows us to solve for one point of intersection. We'll see that in just a moment here.
Solve the following system by substitution. 2x plus y equals 3, 4x plus 3y equals 5.
So to solve this system here by substitution, first of all, I'm going to label those two equations here. There's equation 1 and equation 2. To solve this by substitution, I'm going to choose one of them, and I'm going to isolate the variable there, like I was showing you prior to this. Now, in a lot of cases, it's a very natural thing to solve for y, because you're used to this idea of solving for y, to put it into slope-intercept form, to graph it. When I look at these two together here, the easiest one that I can see to work with here is equation 1, okay? And when I isolate the y, I do that by simply bringing the 2x term over, so I get y is equal to negative 2x plus 3. Okay, so now think about what we were saying just a few moments ago here. Every point on this line, sure, it has coordinates x comma y, but specifically every point on this line is going to be x comma negative 2x plus 3. Okay, That is every point on this line because that is what y is. And now it's just in terms of x. Okay, it's just in terms of that variable x here. So now what I'm going to do is I'm going to substitute this point. Okay, we're going to sub this into 2. Okay, because we know that there's a point of intersection between these two lines here. Somewhere on this line, okay, at one very, very important point, the relationship between x and y is exactly this right here. So when I plug that in to this equation right here, I'm going to be left with one equation with one variable. So just here, to have a look here, maybe I'll zoom in just a little bit so you can see this quite clearly. Okay, I'm going to take this point right here and plug this into equation 2. So 4 times, well in this case it's just x. The point here is just x. Okay, and then I'm going to plug this coordinate in for y. Now sometimes that's not very clear. Some people have a hard time seeing this, but this is my y coordinate, this whole thing. So here it's 3 times y, so this is going to be 3 times, and this is going to end up being negative 2x plus 3, this whole expression with parentheses around it. So I'm going to have to do some distribution here in just a second, and this equals 5. Okay, so look how I've substituted this point that I got from the first equation into the second equation. 4x, 3y, and then here's y, so 3y equals 5. It's still the second equation. Now, but notice I've only got one equation now, and I've only got one unknown. It's just x. So now I'm going to expand that out. So 4x, I'm going to distribute that through negative 6x plus 9 is equal to 5. Okay, put those together. That's negative 2x. I'll bring the 9 over, negative 4. X is equal to 2, positive 2. Wonderful. So now I know the x coordinate. Now, what's really nice about the method of substitution is for me to get the y coordinate, what I got to do is go back to one of the originals. And you know what I'm going to do? I'm going to go back to this one. I already know y equals negative 2x plus 3. Well, here's x. So I'm going to take this and go back. I'm going to go back to 1. Okay? And so y equals negative 2 times 2 plus 3. So negative 2 times 2 is negative 4, plus 3 is negative 1. And so now I know the two coordinates of that point here. 2, got that from over here, and negative 1. Okay? So here, I'm going to come over here. This is asking for me for my solution, so I'm going to go way over here. This is the point 2, negative 1. Now remember, if you don't put the parentheses there, it's not the correct answer. It's not a point if you don't put the parentheses around it. It's got to have parentheses. Okay? X is 2, y is negative 1. I'm going to check this real quick here. I already know that this works in equation 1 because I used equation 1 to get it. So I'm just going to do a really quick little check here in equation 2. So 4 times 2 plus 3 times negative 1. Okay, 4 times 2 is 8 minus 3. That's 5. That does satisfy the original second equation here, okay? Left side equals the right side, so yep. That works. That is the solution.
Solve the following system by substitution. X plus 3y equals negative 2. Negative 3x plus 5y equals 6.
So here's an example of a question where to solve for a variable here, the easiest one to solve for here would be the x in equation 1. Because it's a very, very simple move here. If we do that, so we take equation 1 here, we're going to get x is equal to negative 3y minus 2. Now, this isn't something that we always do. I mean, you don't typically solve for x here. And I know that for a lot of people it's kind of uncomfortable, but it is the easiest one to solve for here. So what's going to happen here is we're going to leave the y coordinate all by itself here. The x coordinate now becomes negative 3y minus 2. And this is the point that we're going to substitute in to the second equation. Okay, so we're going to sub this into 2. So here's my point. So equation 2 is negative 3x. Well, this is what's now in place of my x. So it's going to be negative 3x. Okay, there's the x right there. Negative 3y minus 2. Plus 5y, well, the y coordinate is still just the y coordinate, so that's fine, is equal to 6. Now I've got one equation with one unknown. It's the y. I'm going to distribute the negative 3 through, so it'll be positive 9y plus 6 plus 5y is equal to 6. Now something kind of bizarre happens here, because now I'm going to get 14y, but if I subtract 6 from both sides, I'm going to get 0, which means y is equal to 0. Now that's not a particularly happy result. Most of us, when we get 0 for result, tend to go, I don't know, that doesn't feel right. But that's okay. Just keep moving forward with it. So now what we're going to do is we're going to go back to equation 1. Now, typically, what we're going to do here is we're going to take that y equals 0, and we're going to plug it back into this reworked version of equation 1, because x is equal to now, or x now depends on y, so I can plug that in there. So we're going to go back to whatever the other equation was, but in this case it's equation 1. And so we're going to get x is equal to negative 3 times 0 minus 2. That simplifies down really quite quickly to negative 2. And so therefore we're getting the point here, negative 2 comma 0. So we come over here in our solution, we will write negative 2, 0. There we go as our point here. But what we want to do here is we want to check this. Now I'm already fairly confident that that's going to work in equation 1. Okay. What I'm a little iffy about is whether that works in equation 2. Now in equation 2, it was negative 3x plus 5y equals 6. Let's figure this out here. Negative 3x plus 5y, what does that equal? That equals 6. That's what it's supposed to equal. When you look back at equation 2, that's what it's supposed to equal. No matter what point I plug into there, I should be getting 6 as a result. So that's the correct answer, negative 2, 0.
Solve the following system by substitution. 4x minus y equals 3, 6x minus 2y equals 5.
So we're going to solve this question using substitution here. I've got equation 1 again, equation 2. I got to pick which one of these things is going to be the easiest for me to solve or to isolate a variable. And just like the previous two, I'm going to choose equation 1, and this time I'm going to choose the y variable, okay, the dependent variable. Very similar to what we've done in the last couple of questions here, but in this case here, it's going to be a little bit more awkward because there's a negative in front. So anyway, so here's equation 1. We're going to work with this one. I'm going to bring the 4x over first. Now, don't get confused by this. I see a lot of people that think this thing through quite honestly backwards. Okay, I've got a 4x here and a negative. Okay, I am subtracting the y from the 4x. I'm not subtracting the 4x from the y. Okay, so to move that 4x over, if this is a positive 4x, I'm going to subtract it from both sides here. The negative stays with the y. It doesn't go away. Okay, and it's because I'm moving the 4x. This sign happens after it. Okay, we're supposed to be reading these things left to right. Just something to be aware of. So the negative stays there. Now I'm going to get rid of the negative by dividing everything through here by a negative 1, and that's going to give me 4x minus 3. So any point on this line will have the coordinates x comma y. Okay, but that's true. But to be more specific, to make it a point on this line, I have to identify exactly how that y coordinate depends on the x coordinate. So 4x minus 3. So there's every point on that line there. Now, this should satisfy the second equation at some point here, and we're going to figure out what that is. So what we're going to do is we're going to sub in to, sorry, not 1, we're going to sub it into 2. Okay, so now 6x, well, here's the point, x is going to be 6x, that's fine, minus 2y. Well, in this case, y is 4x minus 3, and the result should be 5. So let's multiply that through. So it'll be negative 8x plus 6 when I distribute that through. Don't forget about the sign. Okay, negative 2 times negative 3, that's positive 6, is equal to 5. Now I'm going to simplify. 6x minus 8x, negative 2x. Bring the 6 over, just subtract it. So 5 minus 6 will be negative 1. And so x is going to equal 1/2. Now, I know, oh, why did it have to be a fraction? But you know what? That's okay. It's not a big deal. Okay, so we're going to take that 1/2, okay, and we're going to substitute that back in to one of the original equations to get the y coordinate. Well, why not use this one? Because it's already set up beautifully to evaluate for y. So let's do that. So let's sub this in. Sub in to now equation 1. So y is going to equal 4 times a half minus 3. Well, okay, 4 times a half is 2, minus 3 is negative 1. And so therefore we're getting this point 1/2 comma negative 1. So this is the solution, okay? The point, remember you gotta put it in parentheses, okay? 1/2 comma negative 1. Now I'm going to check this. I know that it works in equation 1. What I'm a little concerned about is that it's got to work in equation 2. So I'm just going to double check that. So I'm going to plug this into 2, and we're going to get 6 times a half minus 2 times negative 1. Okay, let's just think about this thing through here first. 6 times a half is 3. Okay, a half of 6 is 3. Negative 2, or minus 2 times negative 1 is going to be positive 2. 3 plus 2, 5. Well, look at that. That's what it's supposed to equal. No matter what point I plug in there, it should be 5. So that's good. That works. So 1/2 comma negative 1 is our solution. I know we don't like having that half in there, but that's okay. It worked.
Solve the following system by substitution. 8x plus y minus 2 equals 0. 3x plus 1/4 y equals 0.
So this question right here, when we take a look at equation 1 and equation 2 here, we're going to isolate a variable here. You know what? It really doesn't matter how you do this. I would suspect that a lot of people would look at this first one and say, I'm just going to isolate the y real quick here. And that's great. I have no problems with that. I suspect even more of you, though, will look at this system right away and say, no, I don't like that. I don't like that right there. And so what I suspect a lot of people are going to do is you're going to multiply that second equation through by 4. And what we're going to do is we're going to rewrite this system. So we're not going to do much of that first equation because really we don't really care that much about it. That's fine. But equation 2 did not look very pretty. So we're going to multiply every term here by that denominator. And I can do this because as long as I do it to both sides of an equation, okay, it maintains it's still equal. Okay, it still stays an equation here. So 4 times 3x, 12x. But what's beautiful about this is 4 times 1/4 y just becomes y. And 4 times 0 is 0. So in this case right here, now that I've taken that system and made it a little prettier for myself, well, now I'm a little bit tempted. You know what? I think what I'm going to do is I'm going to isolate the y, but I'm going to isolate the y from equation 2. So I'm going to use equation 2 here, and I will get that y is equal to, when I bring that over, negative 12x. It's just a much simpler equation than it would have been over here. Not that this would have been terribly complicated. Okay, it would have ended up being just negative 8x plus 2. But this is better. So now I'm going to take that value and I'm going to sub this in. We're going to sub in, okay, to equation 1. And so now that is 8x. Oh, sorry. I'm sorry. I should go back here. I've been trying to be consistent about this. This means that the point that I'm using here is the point x comma negative 12x. Okay, that's the point that I associate on this line here. There's no y-intercept, or sorry, the y-intercept is 0, I should say. And so that makes it a little bit easier to work with. I'm going to plug that in. So 8x plus negative 12x minus 2 equals 0. Okay, so I'm putting that in brackets right now because I want to make sure that I mentally separate or put this into steps here. I am replacing in this step right here the y with negative 12x. Okay, so everything inside those parentheses there represents what is inside the y there, or what the y represents. Now in my next step, I'm going to drop the parentheses and I'll get 8x minus 12x is going to be negative 4x. And then bring the 2 over, so equals positive 2. And now when I divide, I'm going to get x is equal to negative 1/2. Oh, there it is again. Fraction. Ooh. But again, not such a big deal, okay? Because I'm going to take this, I'm going to substitute that back into one of the original equations to get what y is equal to. But you know what? I've got a beautiful little equation right here. That's a reworked version of equation 2. This is the one to work with. So we're going to sub this into equation 2. So y is going to equal negative 12. And again, I'll put parentheses here to identify that this is all supposed to be x. And negative 12 multiplied by negative 1/2 is positive 6. And so we're getting the point here, negative 1/2, comma, positive 6. So there's my solution. I come over here, I'm going to write this in the little spot here, make sure it's in parentheses. I'm going to keep saying that, okay, because hopefully you'll remember to keep doing that. So negative 1/2, comma, 6. Now we're going to check it. I already know it works in equation 2. That's where I got the other coordinate there. But I'm going to check this now. We're going to check it in equation 1. So 8 times negative 1/2 plus 6 minus 2. Well, what does that equal? Well, 8 times negative 1/2. Let's think about that. Negative 1/2 of 8 is negative 4. Plus 6 is going to be positive 2. Minus 2 is 0. Well, that's exactly what I was hoping for. Equals 0. So that's true. That works. So negative 1/2, comma 6 is the correct solution to this.
Solve the following system by substitution. Half x minus third y equals 2. 2x plus 3y equals negative 5.
All right. So for this system right here, okay, we're going to label it equation 1, equation 2 here. Okay. Again, my suspicion is that for a lot of you, when you look at this, you're going to say, oh, yuck, I don't like equation 1, okay, because you don't like the fractions here. And because this is an equation, that is okay. We can fix this, okay? But I'm going to multiply this by some sort of constant here that's going to allow me to eliminate those denominators. And in this case here, it's going to be the least common multiple of 2 and 3, 6. So I'm going to multiply equation 1 here through by 6. All we're doing right now, by the way, all we're doing is making the system look prettier, and then we'll start to solve it. Now, I know there's going to be a whole bunch of you out there that are going to be totally capable of just picking one of these variables or whatever variable and isolating it and moving with it because you don't mind the fractions. Just if that's you, that's wonderful. Keep it to yourself because most people don't feel that way, okay? Most people are going to be way happier getting rid of those fractions there. But we can do that very simply. Multiply that through by 6. And now this is a half of x multiplied by 6 is going to change that into 3x. A third of y multiplied by 6 is going to be 2y. And now don't forget this is going to be equal to 12. Okay? And I don't really need to do anything to this second equation. It's already fine here. Now, this puts us in an interesting situation here because solving for one of these variables, no matter which one I pick, is not going to be particularly easy. And in fact, we're going to end up with a fraction regardless of what I end up doing here. Okay? But I took that first step there because I suspect that's what a lot of you will do. And there's nothing wrong with it at all here. So really, I just got to pick one of these things and isolate. It seems the last few, most of the questions that we've looked at, I've been working with equation 1 here. So I tell you what, just for funsies, let's choose equation 2, and we'll stick with y. A lot of people are going to be happier getting rid of y. Isolating y. Let's isolate y here. So equation 2, we're going to isolate y. That's the first step is going to be to bring the 2x over. Okay, there are two terms here, so I need to move the term without the y over, and I'll subtract it. And now I'm going to divide by 3, so I'll get y is equal to negative 2/3 x minus 5/3. Okay, well, it's a little ugly because I got these fractions in there, but it's unavoidable, okay, at this point. Now, that means that every point on this line has these coordinates, okay? X comma negative 2/3 x minus 5/3. Now, I got that from equation 2, so now we're going to substitute that back into equation 1. So we're going to sub into, whoops, wow, that's terrible. We're going to sub into equation 1. So here we go. So equation 1 is going to look like this. Now I'm going to work with my pretty version of equation 1, not the ugly one. So this is going to be 3 times x minus 2 times, and here we go, negative 2/3 x minus 5/3. I put that all in parentheses so that I realize that all of this is y. Okay? That is the y coordinate. So when I plug this into my equation 1 here, okay, it's negative 2 times y. Again, what's in parentheses, that is the y. That's all I'm doing in this step. everybody, all I'm doing in this step is making that substitution. I'm not doing any other fancy little math here. Now, I'm going to distribute the negative 2 through, so this will become 3x. Negative 2 times negative 2/3 is going to be positive 4/3 x. Do not distribute the 2 to the numerator and the denominator. Okay, don't do that. This is like negative 2 over 1. Multiply numerators, multiply denominators. Distribute it to the second term here, and you'll get positive 10/3 equals 12. Okay, good. Now, I've got one equation, one unknown. I got fractions here, so what I'm going to do is I'm going to get rid of the fractions by multiplying by that denominator 3. This will give me 9x plus 4x plus 10 is equal to 36. Oh, well, I like that. Okay, that's pretty. So 9x and 4x is 13x. Okay, subtract the 10, we get 26. Oh, well, x is a nice value. X is equal to 2. Good. Now, I'm going to go back into one of the originals, but you know what? I'm going to go back into my little equation right here where I solved isolated y here. So that was equation 2. So we're going to sub into 2, and we're going to get that y is equal to negative 2/3 of 2 minus 5/3. Okay, well, negative 2/3 of 2 is going to be negative 4/3 minus 5/3. Well, the denominators are the same, so I really just need to combine the numerators, and this is going to be negative 9 over 3. Well, that's just negative 3. So we're getting the point here, 2 comma negative 3. Wonderful, that's a great little point. So 2 comma negative 3. But we got to check that. I already know that it works in equation 2. I mean, that's where I got it. Okay, I mean, unless I really screwed something up here, I'm pretty confident that it works here. So I'm going to check this in equation 1. Now, I did some work on equation 1. Okay, I beautified equation 1 here. I should probably go back to the original and see if it works in the original, just in case I screwed something up. Okay, so we're going to take that point here, 2 negative 3. We're going to put that back into the original. So 2 over 2. Whoa. That's not the right equation. What's going on? 2 over 2 minus negative 3 over 3 equals 2. Is that true? 2 over 2 is 1. Minus a negative. Okay, that's a positive. Positive 1? Yeah, 2. That's what we were looking for. We wanted it to be equal to 2. So that was the correct solution. Okay, we had to go through a little bit of unpleasantness with the fractions here, but you know what? It wasn't all that bad, and we got the correct answer. Good.
Solve the following by substitution. 3 times 2x plus 3 minus y minus 8 equals negative 1. 5 times 1 minus 3x minus 2 times 4 minus y equals 42.
Okay, this question here, it's got a little bit more going on in it, but it's just preliminary work that you have to kind of deal with prior to solving this system here. So here's equation 1. I got a little bit of overlap here from the previous question, but whatever. Equation 1, equation 2. Now, in the previous question, I did a little bit of simplifying to beautify the question, to make it look better and easier to work with. I have to do the exact same thing here. It's a little bit of different work. Okay, I have got some expanding to do. So I'm going to take equation 1 here, and I'm going to start to distribute these coefficients through. So 3 multiplied by 2x plus 3 will be 6x plus 9. I'll distribute the negative through to get negative y plus 8 equals negative 1. Equation 2, I'll do a similar sort of thing. I'm going to distribute the 5 through, so 5 minus 15x, and then distribute the 2 through, negative 8 plus 2y equals 42. Now, that's not quite done. I'm going to go one step further here. I want this to be in standard form, because it's typically the easiest way for me to start this problem. I mean, usually. So 6x minus y, okay, 9 and 8 is 17, and subtract 17, there's negative 18. Equation 2 is going to be negative 15x plus 2y is equal to, okay, well, I've got a 5 and a negative 8, so it's negative 3 on the left-hand side. So I have to add 3 and that's going to get me 45. Okay, good. Now I've got the system in a form that's easier for me to work with. Now, it's an easy choice for me to isolate a variable because I'm just going to use equation 1. I'll use the y. Okay, because it's only going to take me a couple of steps here. So equation 1 becomes negative y is equal to negative 6x minus 18. Okay, now remember what we said before here, that 6x is in front of the negative y. That subtraction is after it, so it's not affecting the value of this. So I subtract that from both sides, and the negative stays with the y. But now simplify by dividing all the terms here by a negative, and we get that y is equal to 6x plus 18. So every point on this line is going to have the coordinates x comma 6x plus 18. Whoops, sorry, it's right at the bottom there. So I'm going to take this now and substitute it into equation 2, just like we've been doing previous. But this time I'm going to plug it into that simplified version of equation 2, because I'm kind of lazy. So this will be sub into 2. Okay, and so equation 2 is now negative 15 times x plus 2 times 6x plus 18 is equal to 45. Okay, now one equation, one unknown. That's what I wanted. Makes this the thing of beauty. So that's negative 15x. Now I'm going to distribute the 2 through. So plus 12x plus 36 is equal to 45. Putting that together, negative 15x plus 12 will be negative 3x. And I'm going to subtract 36. That's going to get me negative 9. Sorry, not negative 9, positive 9. I'll just change it to a positive. Positive 9. And divide by the negative 3. This is where the negative is coming from. This will end up being negative 3. Good. Now I've got a little bit more room, so I'm just going to keep working down here. Now we're going to sub this into either one of the first equations, but again, I've already got a little equation for y right here by reworking equation 1. So I'm going to substitute this into equation 1. So this will be y is equal to 6 times negative 3 plus 18. Well, that's negative 18 plus 18. Ooh, there's a 0 popping out. Okay, well, that's a little weird, but that's okay. So this is negative 3 comma 0. So I suspect right now that my solution here is the point negative 3 comma 0. But you know what? I'm going to check this. I already know that it works in equation 1. I use that to get the y coordinate. So I'm going to check this in equation 2. And I'll go right back to the original, just in case I messed something up. Okay, I'm going to go right back to the original. So this will be 5 times 1 minus 3 times negative 3. There's my x. Minus 2 times 4 minus 0. Now we're going to see what that equals. It should equal 42, but we'll check it out here. Got to do this, you got to obey order of operations here. So this is negative 3 times negative 3 is positive 9. Plus that 1 is going to be 10. 5 times 10, 50. The 0 is not really doing anything. So this is going to be 50 minus 8. Oh, and there it is, 42. So that is the correct solution.
Tickets are sold for the Senior Safari Day at the Greater Vancouver Zoo. Merrill buys 5 admission tickets and 3 train tickets and pays $65. Howard buys 2 admission tickets and 1 train ticket and pays $25. Create a system of equations to determine the price of each type of ticket.
Okay, so to start word problems here, one of the first things we got to do is identify the variables. Okay, so I'm going to now I would probably lean the way a lot of other people lean here. Granted, I know I'm looking for the price of admission tickets and I'm looking for the price of train tickets. So, okay, maybe using the variables A and T makes sense here. But you know what, I'm the kind of guy who says, let's let X equal this is the cost of admission. And I'm going to let Y equal the cost of a train ticket. I like the good old staples, X and Y, okay? Now, it doesn't have to be X and Y. It could be anything. In fact, you could make this Y and X. It doesn't matter what you do in terms of labeling here, as long as you're there from this point on consistent with it. Okay? That you don't change anything. Now, okay, coming up with equations can be really, really difficult, and I understand why word problems really freak a lot of people out. Okay, because it has very little to do with the math. It has almost everything to do with the translating between the English and the math here. But what you should know here is that typically, and I'll write this up here, typically sentences, or if you want phrases, equal equations. Okay, in almost every case here. Now, where the variables come from is what the question's asking for. In this case here, create a system to determine the price of each type of ticket. Okay, I don't know the price of the tickets, that's what I'm looking for. And that's why my X and my Y here refer to those specific prices. Now, let's look at the sentences here that are giving us information. It says, Merrill buys 5 admission tickets and 3 train tickets and pays $65. Okay, well what that means is 5 admission tickets, okay, 5 X's, plus, that's and, 3 train tickets, 3Y, put those together, that's a total of $65. Okay, and there's my sentence. The next sentence, Howard buys 2 admission tickets, okay, 2 admission tickets, and 1 train ticket, and pays $25. Well, and there's that second sentence, there it is. So sentences become equations. And now I've got a system of equations that simply needs to be solved. Now I just approach this the way I've been doing it prior to this. So here's equation 1, here's equation 2. And I can see right now equation 2 is going to be the easier one to work with, because to solve for y, so here's equation 2. To solve for y, I simply bring the 2x over. So negative 2x plus 25, which means every point on that particular line will have coordinates x comma negative 2x, okay, plus 25. Maybe I'll zoom in just a little bit here. Okay, negative 2x plus 25. Now, I'm going to now substitute this into the other equation, into equation 1. So we're going to sub into equation 1, that point. So that's going to get us 5x plus 3. Now, again, y, I'm going to put this in parentheses here so that we identify very, very clearly what the y is. Okay. Now it's just, I've got one equation, one variable. I'm going to distribute, simplify, and solve here. So 5x plus, let's distribute the 3 through. So, whoops, sorry, let's distribute the 3 through, and I start right away not doing that. Positive 3 times negative is going to be negative 6x plus 75 is equal to 65. Okay, well, 5x minus 6x is going to be negative x. And bring the 75 over, and we're going to get negative 10. Oh, the divide, and we get x is equal to 10. Wonderful. Now, I'm going to substitute this into one of the other equations. Okay, it doesn't matter which one, except I used equation 2 to isolate the y. So I've already got a wonderful little equation here. So let's substitute that into equation 2. So sub into 2. So y is equal to negative 2 times 10 plus 25. Well, let's just think about that. That's going to be negative 20 plus 25, 5. Okay, good. So there I've got this point here, now, but I got to be careful how I answer this. Okay, I've got the point now, 10 comma 5. We're going to check it. Okay, I used equation 2 to get the y coordinate. So I'm going to check this in equation 1. So 5 times 10 plus 3 times 5. What does that equal? Well, 5 times 10 is 50. 3 times 5 is 15. That's 65. And that is exactly what I was expecting, okay? Okay, the right-hand side of equation 1 is 65. Now, this is not the answer to the question, though. I got to be clear about this. The admission tickets or admission costs, well, which variable was admission? Admission was X. So admission costs X, $10. Train tickets cost, well, how much did, which variable was the train ticket? Well, train ticket was y. Ah, okay, so train tickets cost $5. And that's what you really need to do. There needs to be some interpretation of the results.
A math test has short answer questions and word problems. A short answer question is worth 2 marks and a word problem is worth 4 marks. There are 11 questions for a total of 30 marks. How many questions of each type are there?
So once again, we're looking at a word problem here. And once again, the first thing we got to do is figure out what the variables are going to be. Now, the last thing here, well, actually, this question here doesn't specifically tell you what you're supposed to do. There's a little bit of an error there, but what we're supposed to do is figure out the number of short answer questions and the number of long answer questions or word problems here, okay? So what we're going to do here is we're going to let, and again, I'm going to go back to x and y. We're going to let x equal the number, okay, of short answer questions, and we'll let y equal the number of word problems. So now we're going to look for equations to pop out of sentences here. So we're told here that a short answer question is worth 2 marks and a word problem is worth 4 marks. There are 11 questions for a total of 30 marks here. So, okay, in this case here, what's happening is the equations have actually been split up over 2 sentences. So this doesn't follow the normal pattern here for that. Okay, what's happened here is we know that there are 11 questions. Now, that's a total. X is the number of short answer, y is the number of word problems. That means x plus y is equal to 11. Don't get this confused. X and y are not scores. They're the number of questions. So you can't add x and y and get, for example, 30 marks, because that's not what these numbers refer to. However, a short answer question is worth 2 marks and a word problem is worth 4 marks. Now what that means is if I have 2 marks for every short answer and 4 marks for every word problem, then the total number of marks plus marks equals marks, total marks. And that you can do here. You just got to be careful with this. So here's equation 1, here's equation 2. Obviously, the easier question for me to equation to work with will be equation 1 here. So I'm going to take equation 1, and like most people would do, I'm going to solve for y. So y is going to equal negative x plus 11. So every point on that line is going to have the coordinates x comma negative x plus 11. Okay, now, actually I will zoom in just a little bit. We're going to sub this into equation 2. So 2 times x plus 4 times negative x plus 11 is supposed to equal 30. So 2x, we're going to distribute the 4 through, so minus 4x plus 44 is equal to 30. And now again, one equation, one unknown, relatively simple to solve. 2x minus 4x is negative 2, negative 2x. Subtract 44 from both sides. Okay, and what do I got here? 30 minus 44 is going to be minus 14. And when I divide, I'm going to get x is equal to 7. Okay, now we're going to substitute this back into equation 1 here. So we're going to substitute that into 1. And actually, we'll get really, really quickly here, because just watch this. Negative 7 plus 11. Okay, well, what's the difference between 7 and 11? Well, the answer is 4. So it's going to be 4. So I've got this point now, 7 comma 4, that I have to check. Now, I used equation 1. Okay, I used equation 1 to get that y coordinate right there. So I'm going to check this in equation 2. So that'll be 2 times 7 plus 4 times 4. Let's just think about what that equals. 2 times 7 is 14. 4 times 4 is 16. Well, 14 and 16, that's 30. That's exactly what I wanted. Good. There it is. Okay, is equal to 30 here. So now I just have to interpret this result. So what this means is that there are, okay, well, how many word problems are there? Sorry, how many short answer problems? Short answer problems. Well, short answer was x, so it's going to be 7 short answer questions okay? And the y coordinate was the number of word problems, so that means 7 short answer questions and 4 word problems. There you go.
Annika's class raised $800 by selling $5 and $10 movie gift cards. The class sold a total of 115 gift cards. How many of each type of card did the class sell?
So similar to the previous question here, in this question we're trying to ask how many of each type did the class sell here. So how many $5 gift cards, how many $10 gift cards? So that's the unknown here. So first of all, we're going to start off with a let statement. Okay, we're going to let, and again, I'm going to go back to it. We're going to let x equal the number of, let's say, $5 gift cards, and we'll let y equal the number, of $10 gift cards. And I'll zoom in just a little bit here. Okay, now that first sentence, actually, the first 2 sentences contain the information that we need. So the class raised $800 by selling $5 and $10 movie gift cards. Well, okay, let's do an equation about money. Okay, so I know that if I sold X of the $5 gift cards, I'm getting $5X dollars. If I sell Y of the $10 gift cards, I'm getting $10Y dollars for a total of $800. Now, the next bit of information, or the next equation, comes from this one right here, the second sentence. The class sold a total of 115 cards. Okay, a total of 115, meaning that X plus Y, number of cards plus number of cards, is equal to the number of cards. Okay, and so now we're going to, we got our 2 equations right here. Now what we're going to do is pick one of the equations, and very likely equation 2. We'll take equation 2 here, and we'll solve for y. And so we get each coordinate on that point is on that line here is going to be x comma negative x plus 115. And I'm going to sub that in. Okay, we're going to sub in to number 1. So we're going to take this point right here, x comma negative x plus 115, and go into equation 1. So equation 1 is going to end up being 5x plus 10, and we'll put this in brackets, negative x plus 115 is equal to 800. And we'll distribute that through. So 5x minus 10x plus 1,150 is equal to 800. Okay, well, 5x minus 10x is negative 5x. Okay, and if I bring the 1,150 over, now I got to think about this a little bit, but after a little bit of thought, I see that that's going to be negative 350. And if I divide, I will get that x is equal to, that's going to be negative, whoops, not negative, sorry, the negatives will cancel. It'll be 70. Okay, so we see that we sold 70 of those $5 tickets here. Now, we're going to sub this into the other equation right here, the one that we're missing. So essentially what this is going to amount to here is, what is negative 70 plus 115? Well, what's the difference between 115 and 70? 45. Okay, so this means therefore y is equal to 45. So we've got this point here, 70, comma 45, and this is our proposed solution here. Now I got that by putting that in equation 2. So I'm going to check the answer by going into equation 1. So 70, so this will be 5 times 70 plus 10 times 45. And let's just see what we get here. So this is going to be 350 plus 450. Yeah, that equals 800. That's exactly what I wanted it to equal. So this means that we ordered, how many did they sell here? I'm sorry, I've got this backwards here. They sold 70 $5 tickets. And what did we sell? 45 $10 tickets. That's what we're looking for. Good. And so there you go. That's how you use substitution. Okay, you isolate a variable, and then you get the point out of that, and you can plug that point into the other equation to create a single equation with a single variable that you can solve.